to do this problem. We're trying to find an antiderivative for this integrand, 7 sine 4th x times cosine squared x. One way to do it is to think of sine to the 4th of x as sine squared, quantity squared. And then sine squared is 1 minus cosine squared, trigonometric identity. If you square that binomial, you get this perfect square trinomial. If you distribute the cosine squared, this is what we're working on right here. We can break this apart like this: 7 antiderivative of cosine squared minus 14 antiderivative of cosine 4th plus 7 antiderivative of cosine to the 6th power. To give you an idea, cosine squared, to find an antiderivative, you use this half angle identity. Cosine squared is the same as 1 plus cosine of 2x all over 2. And now you can replace cosine squared with this right here. And the antiderivative of 1 is x. Antiderivative of cosine 2x, using u substitution if you want, is 1/2 sine of 2x. Distribute the 1/2. So the point is, if you do this off on scratch paper or off to the side, this red block is what goes right here. And then you can do the same thing for cosine 4th. I'll give you a head start. Think of it as cosine squared squared. This is cosine squared, half angle identity, squared. If you square that quantity, you get this mess right here. So I can break this antiderivative into this. Antiderivative of cosine 4th is 1/4 antiderivative of this. Well, that's a pain, especially this one, cosine squared 2x. Well, that's kind of like this one, except we have a 2 here, so you'd have to do a little u substitution. But if you go to MathLab, or I just typed integrate cosine 4th x in Google search and searched, and MathLab came up, and I clicked on that, and there's an antiderivative right there. And then you can do the same thing for this cosine 6. What's an antiderivative of cosine 6? Same basic technique, but you'll be raising this half angle identity to the 3rd power. It gets really painful. I'm not going to go into that. I'll let you go to MathLab to try to figure out what the antiderivative is, but I did it all. Here's what it looks like. Here's your original function. Here's what I found, at least one antiderivative. And if I take the derivative of that, I should get the integrand. And this graph right here is both the graph of little f of x and big F prime of x, and they are identical. So I'm pretty confident that that is one possible solution for the antiderivative of f of x. Okay, there you go. That's a very long, tedious process, but I hope that gave you some idea how to proceed. If you have any questions, post a comment.